everybody, my name is Miss Cassie. I work for the City of Austin Watershed Protection Department, and today I have a fun activity to show you. I have brought our Aquifer model to share with you. So we're going to have a little scientific investigation. So before we get started, I thought you could help me set it up. It's a lot like a fish tank. So in the back here we have a lot of water, and you see right here we have, it says water level. So I'm just going to fill that up to the top. All right. And this is a pump. It's an electric pump that when it's running, when we turn it on, it's going to circulate the water through the model so that we can see how water flows through the aquifer. So I'm going to fill this up with water and then I'm going to plug it in. So we've set the model up. We've got it running with water and our electric pump. The first thing I want you to notice is we have different layers here. So our first layer is a sand aquifer. We see sand aquifers mostly in East Texas. Underneath the sand aquifer is a gravel aquifer. We see those kind of aquifers mostly in West Texas. And then on the very bottom here in gray, this is representing what we have here in Austin, Texas. It is our limestone aquifer. And of course the one that we have here is called the Edwards aquifer. So you might notice that we have all these vertical tubes that are coming from the top and going down to different levels in the model. These tubes are representing areas on the surface of the land where pollution and water can enter the different aquifer systems. So we're going to step through a couple of examples up here. So basically this is all above ground and this is all below ground. This is our example of karst limestone. So it's all these holes in the limestone where that water from the surface can trickle down and work its way down into the aquifer. Now if we were to take, here's a diagram, if we were to take a big cutaway of the aquifer here we have the city. And then we have all these different ways water can work its way down through the rock layers. We have sinkholes, we have caves, fractures, and faults. And it travels down and then it hangs out down here in the aquifer. It travels for a little bit and then it will come up to a point and it will resurface in the form of springs. And of course we have our very famous Barton Springs here in Austin, Texas. The first area that we're going to investigate is the recharge area. So this blue dye is going to represent some kind of pollution that's being introduced at the surface. And if you watched the last video, we could talk about Sally and how she changed the oil in her car. So this blue dye will represent some oil spilled in that recharge zone. So I'm just going to add a little bit of dye here. And you'll see it moving down right now. Then I have a squirt bottle that represents rain. So we're going to see what happens when we rain on top of that oil. I want you to look really carefully down here. And what observations can you make? Where is the pollution traveling? Is it going fast? Is it going slow? All right. So you might have seen it traveled all the way across this area, across the limestone aquifer, and it made it way up here, and now we see it actually is what we call a discharge area. So you see all this pollution. This is kind of like our Barton Springs area. This is where the water is exiting or coming out of the aquifer, and you can see how polluted it is. So something that happens that far away can affect things. Our next area of investigation has to do with a lake area. So this is surface water. This is going to be a lot like our Ladybird Lake. And you see here we have a grassy area right next to the lake. This represents, let's say it represents a dog park. So my next pollution that I'm going to introduce is a green dye that's going to represent some dog poop. We have some people that went to the park and didn't clean up after their dog. So we're going to put a little bit of this green dye on the grass there. And of course then, you can see already it's seeping into our lake. And now we're going to rain with my water bottle and see what happens. Once again, what are our observations? What do you notice about where the water is going? All right, so you can see that it doesn't take much for some of that dog poop to wash into our lake. So we certainly don't want to swim in that. And it carries a certain kind of bacteria called E. coli that can be very harmful. So it's a really good thing that we need to pick up the dog poop every time. Our last example of pollution has to do with wells. So wells are places where people, oftentimes in the country, in a rural area, they don't have city services. So they have to actually dig a hole in order to get down to the water so that they can have water at their house. Now a lot of times these wells, they'll either dry up or they just stop using them if they get hooked on to city services. So then it becomes just a hole in the ground. And some people put trash in the hole and they don't realize that it's all connected underground. So what we're going to do, my red dye represents trash in a well. So I'm just going to put a little here, maybe a couple of drops. All right, and then we're going to make it rain again. So you see, we're going to make our observations once again. Do you think the water is traveling fast or slow? And where does it end up? So once again, ending up in our springs area, our discharge area. A lot like Barton Springs. And of course that's the home to our endangered species, the Barton Springs salamander and the Austin blind salamander as well. So you can see, even if the person doing this didn't realize, they thought it was just a hole in the ground that was abandoned, but it was still very much attached underneath the ground to the aquifer and also to this well right here. So the people who are drinking water off this well, it could pollute someone else's well. Thank you for joining me today when we were doing our investigation of the Aquifer model. Just remember, all the things that we do above ground can sometimes affect what's below ground in our aquifer system. If we have fertilizer, pesticides, herbicides, any kind of chemicals in our watershed, if we take our dog for a walk and we don't pick up the poop, if we change oil in our car and we spill the oil and don't clean it up, all these things make a difference in our water quality. Please visit our website at the bottom of the page. We'd love to see you there. Bye-bye.